All right, this is going to be lesson 2-9. We are on product rule. This is our second day of advanced derivatives.
Yeah. I'm just joking.
So, yeah, we are on Synergy. I assume that we knew it, but I should have asked you, right? All right, so we have our setup ready to go. So let's knock these down. So we've already done this rule. I've kind of informally gone over. Oh, you just take the derivative of each individual component. I'm formally going over it now. Here we go. So when I have distribution, and I'm on the far left over here, 2 times x, I'm doing distribution with 2. I do 2 times x, which is 2x, and 2 times 3, just shout it out. 6. The same thing happens with the derivative. I can distribute the derivative. So I'm going to say d dx, the derivative of x cubed, and that becomes what?
3x squared.
3x squared.
We said that all three of us said that together.
And then I take d dx, the derivative of 4x squared, which is 3, 2, 1.
8x.
8x, yeah. So it's going to be plus 8x. This is the addition rule. We've already done this. This is review for us, right? Nods our heads. Yes, we've done this before. Okay. So let's go ahead and try it again with our second example. So d dx, I'm going to multiply this over. So d dx of this term, there's one giant term here, and the derivative d dx of the second term. There's 2 terms here that I have to take the derivative of. And we have to be careful here. So let's go through this slowly. So I don't care about doubter quite yet. I just care about what outer is. What is outer of this function right here? Yeah, so then what is doubter? Tell me what to write for doubter.
Is it 5 over 2x minus 1?
5 over 2x. Ooh, yeah, you are correct. 5 over 2x minus 1. Okay. This is something that's commonly forgot with the addition rule, and it's dinner. You starve to death. You don't have any food. Don't forget dinner. Never forget dinner, even when you're doing addition rule.
Confused. But you look really scared.
I didn't mean to be scared. I was like really confused what was going on.
All right, what is dinner? 2. So,
Wait, why is it time? I
so
get it.
doubter times dinner. So all of that is the first term. Notice how I'm putting parentheses around the derivative of the first term. I'm going to add this to the derivative of the second term. The second term is
3xe?
Close.
3x. 3e to the x.
3e to the power of x, yeah.
Wait, so you don't bring down the x?
You,
Remember with e, you don't do anything.
Yeah. We're in E house. E house is itself for doubter. What's dinner?
1.
1, yeah. So when we hit dinner, we don't have to do anything. And I could simplify this a little bit more by saying that this is 10 over 2x minus 1 plus 3e to the x.
On the first one, the reason why we didn't do dinner is because it's not, right? Like, it's just that.
That's one.
Because, like, that already, like, you know?
So,
that was really confusing.
so are you talking about this term right
On
here?
the first one, the reason why there's no, like, dinner inner, because, like, there's just not, that's why we didn't do 2.
So, yeah, you stop once you hit your constant. So times 2. I mean, if you keep taking the derivative, eventually you get 0, and then multiply everything by 0, it just goes away, right? You can't multiply, you can't take the derivative.
We didn't do dinner on the first one because there was no dinner.
Is that why?
Are you talking about this first one right here?
Yeah.
Okay,
Number one.
this one did have a dinner. What was dinner? What's 3x squared? That was doubter. What's dinner?
X squared.
No. Inner was
Just one?
inner was this. So inner was
One. Just one.
just 1, yeah.
I get it.
And then this term had a dinner of 1 as well. So you can stop once you have dinner equals 1. And I'll write that explicitly on the side notes
So, like, okay.
after I
so
simplify
go-
this problem.
Okay, I get it.
2x minus 1 plus 3e to the x. So let me explicitly write that down. So we always need to look for the inner. Most people will only look for the outer. Always look for inner. So, and then here's your conditional. If dinner equals 1, then we're Gucci, right? We have no worries. You can write Gucci here, or you can write no worries.
Do not write Gucci.
No worries.
And if dinner is not one, then what do we do when dinner is not one? We just multiply by something?
Multiply by the inner.
Close.
Dinner?
Yeah, multiply by dinner. Multiply by dinner. Cool. Let's try example number 3. I'm going to pause here to make sure everyone finishes writing. I don't want to go too fast.
Thank you. No worries. Wait, where was I supposed to write Gucci?
You can either write no worries or you can write Gucci. Or you can write diesel. I don't
Do you
know.
like actually say Gucci or do you just
Like, do you go
say
home
that
and,
to
like,
Yeah,
make-
do
with
you
your
say that
wife?
to your wife?
No.
Like, oh, today was Gucci.
I don't say
How's your
that.
do you
day?
just say it to make us laugh or like is it kind of like a
It's just a vocabulary term that I use when I'm around you guys.
So do you talk more proper with your wife?
Yeah, because she's way more intelligent than I am, and I feel bad about that. I'm trying to level up my vocabulary when I'm at home.
So your wife is smarter than you. Yeah. Yeah.
All right. Let's take the derivative of our third function. Are we ready? Set. First term. Go.
2 sine. Wait, no, cosine. Which
I heard a 2 cosine 3x
correct. Times 3.
times 3
Plus
plus.
just 4. 4. Or is it 4 times 1?
4.
What?
F
What?
of x, and then it's just 1.
No. You're taking the derivative of 4 f of x.
So it's just 4 of them.
No. F of x is a function.
Oh.
So what's the derivative of a function?
0,
1.
I guess.
This is like really think easy. Go all the way back to like first lesson for unit 2. What is the
0.
derivative of a function? Of
One.
any function?
1.
Of any function?
X.
What if I'll give it to you guys. It's f
Infinity.
prime of x.
Oh.
Oh.
Yeah. So those are all excellent guesses.
We were close.
You were close.
Ish.
Ish, I agree. Yeah, f prime of x. And just simplify that a little bit more to get x or 6 cosine 3x plus 4 f prime of x.
You.
I don't say this often enough, but thank you for participating, everyone in here. Like I get in a lot of trouble with other classes not getting them to participate, so thank you,
Who
everyone.
gets you in trouble?
With math, I feel like I have to take a shot at it, even if I'm getting it wrong.
Yes.
Well, like,
Yes.
I just want to put this on record
Did I
for the
get
tape
this?
recorder. Mammoth, you never speak up because some of the teachers are really mean if you're wrong in math.
I'm
Actually, in this school too.
In this school.
I'm,
Not you, Mr.
I'm
Bennett.
sorry if I have ever done that. I know I have at one point or another.
Last year you were.
You were a little
You were
rough
like,
with that.
no.
Well, there's some new teachers.
Okay, not in my class. Okay, let's go on to our next slide.
No, but like Mr. Sully, like if we're wrong, like I like how you like kind of like make us feel like right, but like say
Like,
that
that
we're
was a
wrong
good
at the
guess,
same time.
but
Yeah, you're like that's really really close, but it's
instead of
right.
like, no, you're
like
stupid.
No. Or like
Yeah, to kind of go off on a tangent even more so, I remember watching a documentary about how women in mathematics were treated like 20 years ago, and it was horrible where it was like one woman in the entire room where the teacher would normally say like, oh, that was a good guess, like John, oh, that was a good guess, Bomb, John, or whatever, and then it would get to her and it's like, that wasn't even close. It's like, wow, you're nice to everyone but her, and her guess was almost better than theirs, but yeah, anyway.
Have you ever watched Hidden Figures, Mr. Cinder?
No, I want to.
It's such a
It's
good
really
movie.
good.
I love it.
I actually was like thinking at first, I was like, meh, but then I really
Yeah,
liked
like
it.
I thought it was gonna be like okay,
Like kind of
but, like,
cliche,
Yeah.
yeah.
or like not even
Nice
but it was,
star.
Like, good.
Yeah, I'm working on it.
Perfect.
Whoa, that was really good.
Yeah, thank you. So here's our rule for the day. This is the most important thing. This needs to be in your summaries. This is the product rule. And here we go. This is the definition of the product rule. If I have the derivative of two functions that are being multiplied by each other. So I'm going to say one function was f of x, and then the other function was, I don't know, g of x. I have two functions. The thing that usually triggers you thinking about product rule is, oh, I have like an x and another x. If I see two x's, you're suspicious. Oh, I think I'm going to be using product rule. There's two functions here. This is equal to. This turns into. And then we're going to box this. And it's quite a bit of stuff. It's 4 kind of big terms, so give yourself some room. This is going to be equal to
Yeah.
f of x
Isn't it F prime?
here's the rule, times, I think I'm just going to do parentheses around this. F of x times g prime of x plus g of x, yep, and all of g of x times f prime of x.
Are we supposed to memorize this?
Yep.
Lord have mercy.
So
Did you like my Texas?
let's pause here. Let's digest this. This is the most important thing. I do want to give some time to think about it. What we're really doing is we're taking the derivative of the second function, multiplying it by the first function. You don't even change the first function. It's still the same exact first function. And then you multiply the first function by the derivative of the second function. Okay, you're good. Check that off. Now you're going to add the opposite. Now you take the second function, the exact, bless you, you're going to take the exact second function, don't change it, and multiply it by the first function, the derivative of the first function. And you might be thinking in your heads right now, but Mr. Sindel, there's the commutative property of addition. You're probably not actually thinking that word. But Mr. Sindel, it doesn't matter the order in which you add these. You could do the first one and then the second one. It doesn't matter the order in which you do this. And I'm going to say, yes, you are right, but do it this way. Because when we hit our next rule tomorrow is called quotient rule. I was trying to find it in my notes, but it wasn't there, but I remember. The quotient rule.
Oh, okay.
The quotient rule is this exact form, but then there's a subtraction sign. In subtraction, there's no commutative property of subtraction. You can't switch subtraction. Get used to this form, yeah. Get used to doing the first function times the derivative of the second plus the second function times the derivative of the first.
First function times derivative. Don't listen to me, I'm just talking to myself. Plus. I feel like everybody got really quiet when I started saying that.
So can we make a note underneath this, something that's easier to memorize?
No. Yeah.
First function times the derivative of the second, and then second function times the derivative of the first. 1d2, 2d1. It actually sounds kind of cool.
1d2, 2d1.
Sounds like a robot in Star Wars.
R2d2.
1d2, 1d2.
1d2, 2d1. So it's actually 1 times d2, and then plus 2 times d1. But think about it as 1d2, 2d1. And product rule is always adding. All right, let's try an example.
But it is easy because it goes like 1, 2, and then like 2, 1.
Right. So here we go. Ejemplos.
Thank you so much. Hurting you. Whoa.
So yeah, language needs to be a little bit better in here.
Dude, I feel like when you said it yesterday, we were like foreshadowing for a book that like sin.
All right, ejemplo número uno. Let's take d dx. I want to take the derivative of this function, x squared times sine of 2x. And I'm not going to do parentheses because sometimes you're not going to see them with parentheses. X squared times sine of 2x. Okay. Oh, look. Remember Mr. Sindel's hint? I see two what? I see two x's. You need to be thinking product rule. And maybe I should write that in the sidebar. So first of all, product means multiplication. Oh, I can write product. I want to do this in a different color because this is not really a title. So this is product. First of all, that means multiplication. So whenever you see, and this is kind of the key for today, if you see two X's,
I didn't even do it. It's just because you do it all the time. I like to ignore
be
it.
suspicious.
I'm just-
You just ignore me now.
I realize that like you
Connect in your head two X's, product rule. If I see two X's in here, think of product rule. All right. So let's do this problem now.
I like to see what happens.
Like all of us.
Like balls down.
Like
instead of
going like balls up.
yeah.
All right.
Just see what happens.
So let's apply our rules. So which one is the first function? Which one is our second in this case? Should we just do left or right?
Yeah.
Versus x squared.
So I would say that's function 1. That's function 2.
Uno.
All right. So we're gonna do 1d2. One
Speak in Spanish.
uno de dos. I don't know. Is that how you say it?
He's like, gotcha.
Tacos.
Look, I rewrote the first function exactly. Just x squared. Just 1. Now I'm going to multiply that by d2. What's d2?
Two.
Close. Rosalie has it, I think.
Cos of 2x.
Cosine of 2x.
Plus.
Missing something.
Two.
Times 2. Yep.
Oh, just kidding.
Yeah, but you're right. You're getting ready for the next part of the formula. I could tell. You just forgot dinner. You're gonna starve, Isabel.
Okay.
Oh,
Oh.
times 2.
Don't forget dinner.
Oh, wow.
Oh wow.
All right. What comes now, Isabel? You had the next part for us?
Times.
No, it was the other
Oh,
one.
plus.
Thank you. You got it.
Your mom and she's like, let it go.
Yeah, yeah.
Let go.
All right. Someone tell me what to fill in here.
Sine of x and 2x times 2.
Times close.
2x.
2x, yeah.
And would you do 2x?
Wait, why would it be times 2x?
Ooh, good question. Someone else answer that.
You take the derivative of the first one. So then you like multiply the two down.
Oh, yeah.
Yeah. And I'm going to repeat that for the video. That d1 is the derivative of the first one. Derivative of x squared is 2x. All right. Nice. You got the first example. And that's all there is to it. And I can't even really simplify this. I guess I could put the 2x in front of here and put the 2 in front of the x squared.
Do we have to?
Yes. In my class, always simplify. In my class, always
It's
always
not
simplify.
simplifying, it's moving the...
I know.
Yeah, we didn't even do anything.
But this is what I'm going to have for my answer key. It'll be much easier to see that you know what you're doing.
Oh. God.
No, you saw it immediately, though.
No.
No.
Mr. Sindel, I'm
Yes.
gonna make a note to simplify on the side, but I'm running out of space, and I only want to make one page, or else my notes
Okay.
get out of order.
Well, we have 2 more examples. So, for what it's worth. All right, number 2.
He doesn't know.
I'm going to take the derivative of, let's do negative e to the power of x times natural log of x. And I should make a note here. Sometimes it's really hard to tell what the two functions are. I'm being nice to you. I wrote a little dot here to say, hey, these are being multiplied. Most of the time, they're just going to be squished together, and that means they're multiplied. They'll have to dissect what's going on.
And the 85.
I think I like left it on somewhere and it
All right,
just
here we go. This is going to turn into what? Red means derivative. We are now doing the derivative.
Minus e of x plus
Minus e to the power of x. Maybe, I think we all have an understanding. Go ahead and try to do it on your own paper, and then look up at the board to see if you're doing it correct.
Wait, I don't get the negative ex on the last one. Wouldn't it just be times 1?
Okay, so
E, the derivative just is.
let me make sure I understand your question. You're talking about this part right here.
Yeah.
Why is that negative e to the x and not just 1? Okay, I need someone else to answer that for me.
Because with... No, you
I'm
can.
just kidding. No, I'm always one that gets
You're
it.
multiplying
Really
by a
cute.
lot.
Not exactly. I mean, that's what you're doing, but why is this negative e to the x?
Because when you take the derivative of an e function, it just
It just stays the same.
Oh,
Yep. When you're in e
oh,
house,
okay.
it stays the same. Exactly.
E house.
Yes.
Yeah.
Like,
I'm impressed. You guys are all getting this like right from the get-go. This is awesome.
I thought you said gecko at first.
Gecko.
I was like, wait, what?
And go ahead and simplify.
Oh.
Are you okay?
No, something just beat me, dude.
Oh my god! Last night there were so many moths in my room.
Oh,
Like,
that's so
There was like
gross.
I was like reading on my Kindle and like 3 like landed on the screen and I was just like disgusting.
Okay.
Well, sometimes
Give this guy a little asterisk. Number 3. This one is very hard.
Very hard.
Very hard. You can even write this here. It's very hard.
Wait, what happened to the neg? Oh, I get it. You did mine. It's okay.
Yeah, this plus turned into a minus because of this minus over here. All right, here we go. D dx, the derivative of xy.
That's it?
That's it.
Okay.
All right, what does that turn into?
X in the derivative.
So good luck doing it. What?
Well, that's not.
Wait, do we actually?
Maybe
not-
y is considered an x in some weird.
No, y is considered y. It's a very distinct variable that is not
And
x.
obviously it doesn't fall into our product rule.
It does fall into the product rule.
Sorry.
But there's only one x.
There's an x in the bottom of the derivative.
If you take the derivative of a function, like I did in our previous slide, you just leave it as the derivative of the function because you can't do anything with it. So that's kind of the strategy for our y here. Just leave it as the derivative of y. How do you write the derivative of y? There's a few ways you can write it, and I'm going to write them on the sidebar over here. But try it on your own. I'll give you guys a 10-second head start.
Okay.
Wait, I'm confused on what we have to do.
We're writing the derivative using the product rule.
Just don't talk for 10 seconds.
Yeah, we'll catch up to everyone if we're confused. All right, that was 10 seconds, I think. It's definitely 10 seconds by now. Okay, so I'm taking the first. What is the first? X. Okay, I'm going to multiply that by the derivative of the second. What's the derivative of y? And I'm going to write these out here.
Y prime.
So one way of writing it is y prime. What's another way of writing it?
F of y.
Not exactly. No. Because f prime of x assumes that it is a function that is unknown, but our function is known. Our function is y.
F prime of y.
And I'm going to write it here for us. These are all good guesses. It's dy dx.
What?
Oh yeah, I knew that.
Oh, I can. What?
I kind of remember that too.
Yeah, I remember doing like d dx. I'm going to erase this, so please don't write
And
this
then
part.
It was multiplied by x.
D dx of u was du dx. Okay, I swear that was my pen, not me.
That U was really rough.
Oh, it looks pretty now though.
Yeah.
So you kind of remember doing this, so that's why it's dy dx. Let me,
So would you rather have us put that than y prime?
you can do either or. Y prime is way faster to write, so that's why I choose it. Come on, eraser. All right.
Hoping you couldn't understand.
So I'm going to say that this is going to be time. Ooh, I should be in red now because I'm taking the derivative. I'm trying to. Oh no, I have to undo. Oh, what am I doing? Okay, I'm just gonna.
Oh god.
Can I redo?
You don't know what you're doing.
I don't know what I'm doing. I should just erase. I thought I could undo this little X, but it's way easier to just unrace. Okay, erase, not unrace. So this is going to be X times Y prime plus. Tell me what to write.
Y times x prime.
That was just Y.
Y times.
1.
Oh yeah.
Yeah, Y times 1. So it's just Y. You got it, Joy.
Wait, so how come?
Wait, why is x prime just 1?
Yeah.
But if you take the derivative of the x, then it's just 1. Like,
So that's just
Like,
about
okay.
x, not just any.
Yeah, in our notes, and we can put this on our sidebar too. When I do d
Sorry, why?
dx of x,
Can I one of your
that's equal to dx over dx, which is the same thing, which is 1.
Do I say your third?
No. I literally talked about number 4. Talked all the way for 1.
All right, guys, we're almost done with the notes.
That always happens.
I like want to block and put it. I like told him, I was like, oh my
So if I could summarize the product rule in a really neat way, I mean, we have 1D2, 2D1. I can change it to this. This is our final and awesome rule. I'll change it back to blue. And it is this. If I'm taking the derivative, d dx, this is it's kind of a summary that I'm giving to you of,
So can we write summary?
no, just write this in your notes and then do summary under it. You can rewrite it for your summary if you want, I guess, I don't know.
Cool.
First times second. If I'm taking the derivative of two things that are being multiplied, two things that are a product, this turns into, I don't know why I wrote an equal sign. I should just do an arrow. This turns into, I'm sorry,
You
1
need to redo this video.
D2. I feel weird saying D2 because there's a D3 in our school. Plus,
Isn't the reason why she's
Two.
D3 because like somebody else was D2?
exactly,
Her brother.
Yeah.
2D1.
Edward.
So like he like walked.
This is our beautiful product rule. All right.
Should we start this?
I just don't know how many people live.
Maybe you want to give this a star also.
Hold on.
Sorry, what was that, Caitlin?
How many people live in Sunny Slope? Sorry, that was.
I don't know.
I'm just wondering.
Not very many.
Is it like a cool neighborhood?
I,
have a big house?
it's okay. We'll talk about it after the video. Do we have any questions for the video? For Mr. Sindel right now?
Wait, can I say goodbye?
All right, goodbye, everyone.
Good